Okay, we are solving question number one. The structure of Q in the following reaction scheme is we have to find out. So basically, we have something like an M, which is this one, reacting with excess of phenyl hydrazine, and so it should be forming a molecule which is H C double bond N N H P H, and then we have the stereochemistry from the third carbon as follows. Now, what should be understood is the molecule N is also formed by P on reaction with excess amount of phenyl hydrazine, which means this portion of the stereochemistry of the asymmetric centers is the same for P and M. Okay, so if we can guess, then what we say that maybe P and M are apimers to each other. That being the case, we can say that it will be CHO, then we have OH, H. So that is how the molecule should be as far as the structure is concerned. Now, if you reduce this molecule with hydrogen and nickel, it will be the aldehyde group that will be reduced. So finally, we will have this molecule as the product, which we will assign as Q. And if we compare with the options given in A, B, C, D, we will say B should be the correct answer. Okay, let us try to solve the question number two. So when we are using reagent number one, okay, let us try to solve here. So suppose this is the molecule given to us. Technically alpha beta unsaturated ketone, and that is undergoing the Simon-Smith reaction. So it forms a cyclopropene over here, and this is the molecule we'll have. Now, if this is treated further with Birch reagent and followed by aqueous workup, the answer that will be, or the product that we will be getting, would be something like this. Okay. Now we have question number four, the major product in the reaction we have to find out. So over here, first of all, we have to judge which of the bromines are lying anti to each other. So we will highlight them. So it is this bromine anti to this bromine. So now the reaction mechanism is what? Here the iodide will attack the bromine having the asterisk, and that bond will come in like this, and the bromine that is lying anti to it will be acting as the leaving group. Okay, so as a result we will get the following product. And so here we will say option A is the correct answer. Question number 5 says the diagram that best describes the variation of the viscosity of the water with temperature at 1 atm is. Now here we know that the viscosity of water will be decreasing with the temperature. Okay, and so we will say option A will be the correct answer over here.